Hi everyone, this is my project SigmaLink. It is a vehicle telemetry monitoring platform, and its purpose is to take in telemetry data and be able to display it to the user in real time. So a bit about me. My name is Jakub. I am a second year student at University of Strathclyde, studying computer and electronic systems. I am originally from Czech Republic, and some of my interests involve tech and innovation. I like to do quite a bit of gaming, and I love to go on hikes. So, how did this project come about? Well, within the University of Strathclyde, I am part of a eco-vehicle team, also known as USEV, where we are designing a electric vehicle to consume as little energy and to compete with other students in a competition. Within this, I am one of the few people involved in collecting telemetry data from the vehicle. Now, when I joined, one of the first things that I've noticed is that there is no way for us to view the data that the car is producing while the car is in operation. What we then have to do is stop the car, disconnect everything, take out the hard disk, connect it to a laptop, and only after that can we start analyzing and looking at the data. Also, we had no way of visualizing it. So I decided to change this and design a solution to which we are able to upload data as soon as it's being generated, and in real time we can then see it on a website. So technology tools I used to create this was a Azure Iot Hub, Stream Analytics, Azure Functions, Blob Storage, SignalR, and Bing Maps API. Now, the way it works is that first we start with the vehicle external data, and we are sending it over to a Azure Iot Hub. Once it's received by Azure Iot Hub, a Stream Analytics job takes the data and straight away saves it to a blob storage and sends it also to our HTTP trigger function that uses SignalR link to create a link between the function itself and our front end for it to be able to access this data in real time. Once the front end receives the data, it is then able to display it to the end user. Also using the Bing Maps, we are able to display the position of the vehicle on a map overlay. Now a bit more about the Iot Hub. It is a cloud-based message hub with a two-way communication between the IoT application and an IoT device. This means that it is designed specifically for taking data from a device such as this vehicle and putting it up into the cloud. It is very much scalable, and you can connect up to millions of devices to a single backend securely. Very easy to set up. Once you have your Iot Hub running in Azure, there is just the button IoT devices. You just click on create a new device. Just put in your device ID and everything else is generated for you that you will need for setting up your data stream. So if we look at how this works on the vehicle side, we have a couple of setup, and the most important thing right here is the device connection string that we saw on the previous page. This is what it's actually calling to when we are calling the Iot Hub. Then we just have a function that sends the data over. Now, Stream Analytics is a very effective way of sending real-time events within the cloud. It is also great use with IoT device data, which is exactly what we need in this case, as we need to get our data from the Iot Hub to our Azure function and also store it in the blob storage. So how do we do this? Well, once we've got our Stream Analytics job set up, we just configure our input, which is the Iot Hub, and our outputs, the blob storage and the function, and then just write a simple SQL statement, as you can see here. And at that point, the data is being sent over. Now, Signal R allows the server to send data asynchronously over to the web application and vice versa. So it's a bidirectional open communication. And it allows us to update the website in real time, which is exactly what we need in this case, as we need data to be displayed on the website without us having to refresh it. And it is very easy to set up with Azure. So as you can see here, this is some of the backend code that goes into setting up Signal R. So once we have the Signal R set up in Azure, we also need a negotiate function that the Signal R thing we set up in Azure actually calls to establish the link. And after that, in our backend HTTP trigger function, we have to change our function.json and add this little bit, which connects to the Signal R, and it's saying that we are sending data into the stream. And then at the front end, we are just using a basic Signal R connection, and since it's all in the same on the same server, it's then able to determine how to access this data. So now for a demo of how this actually works. So this is the front end of the website, and I was simulating data from my computer as it would look from the vehicle. As we can see, it's sending over data that includes the number of the message being sent over, then the time that it was executed, and then different data from the vehicle sensors, such as acceleration, position, then GPS location, throttle position, battery, and what speed it's traveling at. Then we are also taking in the location and putting it into the map overlay so that we can visualize where the car actually is on the track. At the bottom here, we can also see some information that stays static. Therefore, we don't have to display it in the table, and it's easier to look at when it's line after line. So some of the challenges I've faced in this project was, first of all, the project structure. I have never worked with having to send data like this and trying to make it all in real time. So I went through probably 3 different iterations of how this project should work. And my first one, as I wasn't really aware of what services to use, I was just trying to do it using basic HTTP trigger functions and some timers. And that would be moving the data around and saving it then to a blob storage. After a conversation with my mentor, he showed me that the Iot Hub is the way forward with this, as is designed specifically for what I need to accomplish it. After that, I had to figure out how to get the data from the Iot Hub, which turned out best thing there was the stream analytics job. The next biggest challenge was designing the front end. I have never designed a front end before, and I decided to build all of it from scratch. So I wasn't using any templates, as I wanted to experience how much time and how difficult it could be designing it. And the next kind of challenge was the timing. There's always extra features to be added. Unfortunately, I started to run out of time and some of the features had to be cut back. So I am planning on working on this project further into the future. And one of the first things would be to improve and redesign the UI, as you saw at the moment, it is not exactly appealing. It gets the job done, but it could do with a lot of tweaks and maybe even integrate things like light mode and dark mode. Next thing would be for the system, for the backend to be able to handle more than one data input at a time. So, as I said, the Azure IoT Hub is capable of receiving millions of data from millions of devices at the same time. However, my function isn't exactly designed in a way to be able to handle this, so that would have to change. Then I would also like to implement a user hierarchy to the system. So as an example, let's say that I was able to implement this system on a racetrack somewhere, and each one of the vehicles would be sending data to the IoT Hub, and then each one of the teams for the vehicle would have their own login that they would use on the front end, and using that login they would be able to access only their vehicle's data. Then there would also be admin users that would then have access to all the possible data, which would also allow them to see all the vehicles on the map at the same time, which would possibly help with management of things. Extra features to be added to the front end would also be for the user to be replay previously collected data from the blob storage. That's why I had the blob storage there in the flowchart layout, as that was one of the features I was working on but didn't get to finish. Next thing would be for the user to be upload their own data from the front end and then be able to play it back. And also for the user to be able to select which data they want to be shown and which ones to be hidden. Overall experience was amazing. I got to create my own project from start to finish, which I never got to do before outside of any sort of university work. And it was a great experience. I got to work on both the front end and back end and got to see how much work goes into both. I got to learn some of the Microsoft Azure services and just see how cloud-based programming works and how it's going to be very useful in the future. Then I also got to learn how to read documentation for external APIs and how to implement an API. In this case, I used the Bing Maps API for the map overlay. I was also debating if to use the Google Maps or Azure Maps, but for this purpose and also me kind of running out of time, it turned out that Bing Maps was very straightforward, and in their documentation didn't even have examples that you can play around with, so very helpful and interactive. Also, it was great having support from the Bit project team and my mentor, so whenever there was anything I needed help with, I could turn to them and all my questions would be answered. So I would like to thank the Bit project for giving me this opportunity and the space to create such an amazing project. I would also like to thank Microsoft for sponsoring this camp and giving us access to their Microsoft Azure features. And last but not least, my mentor Ganesh. He was a great help in the initial stages of designing the structure of this project. So thank you, and thank you for listening.